Unit 12. B. The threat from space. A. It was just after 9 p.m. on June 18, 2004, at an observatory in Arizona in the United States. Astronomer David Tholen was scanning the sky for asteroids when he noticed an object headed toward Earth. He and his colleagues hoped to take a closer look later that week, but, unfortunately, were prevented by rain. By the time the team finally got another look at it, they realized they had a problem. The object was a large asteroid, which they named Apophis, after the Egyptian god of evil. Bigger than a sports arena, it comes frighteningly close to our planet every few years. By December, Tholen had calculated that the chance that Apophis would smash into Earth on April 13, 2029, was 1 in 40. B. Alarm about the threat started to spread. Then, on December 26, 2004, a real catastrophe struck: the Indian Ocean tsunami, which claimed hundreds of thousands of lives. The public forgot about Apophis. Meanwhile, astronomers had found earlier images of the asteroid. The extra data enabled them to calculate its orbit, and they discovered that it would actually fly safely by Earth in 2029. However, this alarming scenario started a race among scientists to find solutions to the threat of large objects striking Earth. C. Every day, tons of dust from comets and pieces of asteroids the size of grains of sand burn up in the Earth's upper atmosphere. Most days, a piece or two of rock or metal, the size of an apple or bigger, actually makes contact with Earth. Yet it's unlikely you'll ever be struck by a meteorite. Very few meteorites are ever known to have hit a person. In 1954, a grapefruit-sized rock bounced off Ann Hodges's radio and hit her as she lay on her sofa near Sylacauga, Alabama, in the United States. She escaped with only a bruised hip and wrist. Since then, there have been some spectacular near misses. On August 10, 1972, an object the length of a car and weighing 150 tons traveled through the upper atmosphere. Hundreds of people saw its bright trail that sunny afternoon as it crossed the sky from Utah in the United States to Alberta, Canada, before flying back out into space. On March 22, 1989, a rock measuring 300 meters across came within several 100,000 kilometers of Earth, which, in astronomical terms, is uncomfortably close. E. There is evidence that, in the past, massive comets or asteroids have struck Earth's surface. 35 million years ago, a 3-kilometer-wide rock smashed into the ocean floor, 160 kilometers from what is now Washington, D.C., leaving an 85-kilometer-wide crater buried beneath Chesapeake Bay. Another giant rock called Titan, 10 kilometers in diameter, smashed into the Gulf of Mexico around 66 million years ago, unleashing thousands of times more energy than all the nuclear weapons on the planet combined. The whole Earth burned that day, says Ed Lu, a physicist and former astronaut. 3/4 of all life forms, including the dinosaurs, went extinct. Astronomers have identified numerous asteroids big enough to cause a catastrophe for the entire planet. None is on course to do so in our lifetimes, but there are many smaller asteroids that could strike with devastating effects in the near future. On June 30, 1908, an object as big as a 15-story building fell in Tunguska, a remote part of Siberia. The object, an asteroid or a small comet, exploded several kilometers before impact, burning and blowing down trees across 2,000 square kilometers. Clouds of tiny particles of dust and ice filled the sky. The particles reflected the sun's light onto the Earth, and for days people in Europe could read newspapers outdoors at night. More recently, in 2013, a 20-meter meteor exploded over Chelyabinsk Oblast, Russia, injuring dozens of people on the ground. It was the largest object to enter the Earth's atmosphere since Tunguska. G. The next time a large object falls out of the sky, we may be taken by surprise, though an early warning system for near-Earth objects has recently been put into place. Sky surveys, like the one done by Tholin, are also helping to fill the gap. Every couple of weeks, says Lou, we're going to be finding another asteroid with, like, a 1 in 1,000 chance of hitting the Earth. H. Within decades, the world's leaders may be faced with a dilemma: what to do about an incoming space object. Few experts are giving this much thought, according to NASA astronomer David Morrison. The number would roughly staff a couple of shifts at McDonald's, he says. Ed Lou, one of these few experts, is working on a plan that employs a spaceship to deflect asteroids. We were originally thinking about how you would land on an asteroid and push it, he says, but that doesn't work well. If the surface isn't solid, you have trouble landing or keeping anything on it. Moreover, asteroids are always rotating. Pulling the asteroid along would be much easier. Rather than having a physical line between you and the thing you're towing, you're just using the force of gravity between them, Lou says. A nearby spacecraft would pull the asteroid off course very slowly but steadily using only gravity. Just a slight change in course could mean missing Earth by tens of thousands of kilometers. K. The drawback to Lou's plan is that it would work only for asteroids up to a few hundred meters across that could be engaged far from Earth. Russian scientist Vadim Simonenko and his colleagues concluded that the best way to deflect a larger asteroid up to 1.5 kilometers wide would be to explode a nuclear bomb nearby. The explosion would destroy smaller rocks. For larger ones, the explosion would burn a layer of rock off the asteroid's surface. The expanding gas would act as a rocket motor, pushing the asteroid onto a new course. As Apophis swings past Earth in 2029, there is a small chance that Earth's gravity will deflect the asteroid just enough to put it on a certain collision course with our planet on the next pass, in 2036. The odds are currently estimated at 1 in 45,000, so a strike is extremely unlikely. Meanwhile, astronomers will continue to track Apophis to learn if it will merely taunt us again or actually strike.